Hello! In this video, we are going to prove the following theorem. The cosine of 2 arctangent x is equal to 1 minus x squared over 1 plus x squared, and the sine of 2 arctangent x is equal to 2x over 1 plus x squared, for all real numbers x. Now, first of all, let's remind ourselves of the definitions we've been using. As for the exponential function, the definition we've mainly been using is the following. For all complex numbers z, e to the z is the limit of the sequence 1 plus z over n to the power of n. Our definition of sine and cosine are as follows. For all complex numbers z, the cosine of z is equal to e to the iz plus e to the negative iz over 2. And the sine of z is equal to e to the iz minus e to the negative iz over 2i. And our definition of the arctangent function is as follows. Let x be any real number and consider the following sequence. Then, the sequence 2 to the n xn converges. And we define the value that this sequence converges to be the arctangent of x. So, all of these guys are definitions. From these definitions, we've proven quite a lot of properties. As for sine and cosine, we proved for all real numbers x, the cosine of x is equal to the real part of e to the ix, and the sine of x is equal to the imaginary part of e to the ix. As for the arctangent function, well actually, we proved a property that involves both the exponential and arctangent function, which is as follows. We proved for all real numbers x, e to the 2i arctangent x is equal to 1 plus ix over 1 minus ix. So this is what we're working with. And we're going to go back up to the top, and I'm only going to write down the important facts that we're going to be using. Which are actually just these. So now, let's get into proving this theorem. To start on the proof, since we're trying to prove a statement about all real numbers, let's give ourselves an arbitrary real number. We'll call it x. From here, we want to show that these two identities are true. Now, we know that e to the 2i arctangent x is equal to 1 plus ix over 1 minus ix. And actually, let's express what this is in rectangular form. What we're going to do is, we're going to multiply both the numerator and denominator by 1 plus ix. If we do that, well, if we expand the numerator, that's just going to be this. And if we expand out the denominator, well, that's just 1 plus x squared. And now, grouping together the real parts and the imaginary parts, we have this. And now, according to our first fact, if we take x to be 2 arctangent of x, well then, the cosine of 2 arctangent x is equal to the real part of e to the 2i arctangent x. But the real part of e to the 2i arctangent x is equal to 1 minus x squared over 1 plus x squared. So, we have proven the first identity. As for the second identity, well, in our first fact, if we take x to be 2 arctangent x, then the sine of 2 arctangent x is equal to the imaginary part of e to the 2i arctangent x. But the imaginary part of e to the 2i arctangent x is just 2x over 1 plus x squared. And so, the second identity has been proven. And so this completes the proof. So this is the result that we've just proven. But also, we've proven some other properties about the arctangent function. In particular, we've proven that the arctangent function is bounded. And we defined the least upper bound of the arctangent function to be pi over 2. And from there, we were able to prove that pi over 4 is equal to the arctangent of 1. And therefore, pi over 2 is equal to 2 times the arctangent of 1. And so because of this, if we compute cosine of pi over 2, well, we can substitute pi over 2 with 2 arctangent 1. And by the fact that we just proved, if we take x to be 1, then cosine of 2 arctangent 1 is equal to 1 minus 1 squared all over 1 plus 1 squared, which is just equal to 0. So cosine of pi over 2 is equal to 0. As for sine of pi over 2, well, again, we can replace pi over 2 with 2 arctangent 1. And if we go to the fact that we just proved, we take x to be 1, then sine of 2 arctangent 1 is equal to 2 times 1, all over 1 plus 1 squared, which is just equal to 1. So sine of pi over 2 is equal to 1. So we have this. And so yeah, that's pretty much it for this video.